So I wanted to do a very short video just on the signs of heights and distances for both mirrors and for lenses, just because that's where a lot of people get confused. So I want to go over that very quickly. With mirrors, we have a focal length somewhere. For this type of mirror, it's here, and for a convex mirror, it's back here. And this is a positive focal. This is a negative focal. And then the things to remember for heights and distances. H is always a purely vertical measurement, and D is a purely horizontal measurement. Suppose we've got an object here. So if we've got an object right up here, DO is always positive, no matter what. DO is always positive. And that's the distance to the straight line here, the back of the mirror. DI can be different places. So you could have an image formed right here, you could have an image formed here, you could have an image formed here. DI is always, again, that purely horizontal distance to where that image is formed. So in all of these, DI is going to be from the image to that line. Now, the rule for DI is always going to be virtual images have a negative DI and a real image has a positive DI. Don't try to think of it in terms of left-right because it's different for these two. If you can remember that a real image is always positive DI and a virtual image is always negative DI, that's the rule that's true in any case. So if we have an image back here, the light can't actually get behind the mirror because it doesn't go through the mirror. So anytime we have an image back here, these are virtual images, which means we have a negative DI. So negative DI, and this is a virtual image here, which means a negative DI. This here is going to be a real image. The light rays will go bouncing off the mirror and actually converge here. So here is a positive DI. And then for our heights, the heights are purely just above this axis is a positive height, below this axis is negative height. And that means that this object here would be a positive height. This here would be a positive height. This would be a negative height. This would be a negative height. And whether it's image or object doesn't matter. Anything above the line, positive height. Anything below the line, negative height. So that's real quick on mirrors. For lenses, so if we have a converging lens, we have focal here, and those would be positive. For a diverging lens, we have focals that are negative because they're actually virtual focals. And let's say we've got an object out here again. We always have a positive DO, always, always, always. And now with lenses, we want the light to be going through. The light is going to come out and it's going to go through the lens, so anything over here is going to be a real image because the light actually ends up over here. Anything on this side is going to be a virtual image because the light is going to go out here and we'd have to backtrace it. Our eye is fooled into thinking there's an image here. So for the lenses over here, if we had an image here, it would be real. Image here would be real. Image over here, virtual. And then same rule as before. Real has a positive DI and virtual has a negative DI. Heights, we have the same exact thing. Above the axis is a positive height. Below the axis is negative height. So this would be positive height, negative height, and anything into here would be negative height, whether it's image or object. So that's just a real quick refresher or a reminder, I guess, on how to figure out the signs of things in the different lens problems or the mirrors problems. So I strongly recommend you don't get in the habit of thinking that a negative DI is left or right. A negative DI only tells you it's a virtual image, which means that it is where we have to backtrace the rays in order to see it. Virtual images for mirrors are going to be here. Virtual images for lenses are going to be here. So the only real rule that you can follow is right here. Virtual is negative DI, real image is positive DI. So I hope this helps a little bit. So heights, positive, negative, and then real virtual for the distances. Magnification, just go over that real quick. A positive magnification means the image is upright, which means same side as the same up-down as the original. Negative magnification means the image is inverted from the original. Magnification greater than 1 means the image is bigger than the object. So the image is bigger, and magnification less than 1 means the image is smaller than the original object. So there's just some real quick reminders on pluses, minuses for mirrors and for lenses. Hope this was helpful.